Today we're going to start with some real-world examples to help you understand what this is about. We have a house. We have a gallon of paint is going to cover about 400 square feet. How much paint would you need to paint the entire back of this house? So it's just asking for the back side. The good thing on that, we're assuming there's no walls or doors in the back. So it's basically just a blank canvas on the back side. So here's your task. We've given you enough information on the front side to break this into shapes that you understand the formulas for. Find the areas of those, and then you're going to put them all together to figure out what your total square footage is. And then use that information to figure out how much paint you need to cover the entire back. Just to make it easy for you, go to the nearest gallon. You don't have to do decimals on the paint because a lot of times they don't want to divide it up that much. Okay? If you need it, on page 70, you should have all of your formulas. William, don't lean in your chair. Page 70 has your step-by-step. How do you break these down to find the areas of each of the individual shapes along with your formulas. So I'm going to let you guys work together as a table. There's only this one problem. We're only doing the bottom part of this page. So you guys are going to finish up this page. I will give you guys 5 minutes to work through this together. You may work as a table. Go. So on this one, and I kind of told you before, right after I turned it off, they kind of gave you a hint right here that this would be a good dividing spot to build this into shapes that I know. So if I do this here, I now have a triangle, I have a rectangle, and I have a rectangle. If you go back to page 70 in your modules, the one I told you to dog ear, it basically walks you through this step by step. Step one is I have to identify the figure. So in figure one, what shape is that? Triangle. Thank you, Jet. So then, step two, I write down my base formula for a triangle. It's 1/2 the base times the height. Step three, I need to identify on my paper the base and the height. That's why I'm glad you guys have these books, because you get to write right in this. So on this, I need to know my base and my height. Well, I can see that the 10 here, remember, for base and height, I would need to build in my magic box. So that tells me this is the 2 lines I need. This would be my height. The base, they didn't actually tell me what this was, though, did they? But they did say that the whole thing is 50, and that's 18. So given that information, I can do the math, and I find out that my base on this is 32. Just subtract 18 from 50. Does everybody understand all those numbers? Once I have my numbers identified on my figure, now I simply put them into my formula. 1/2, I said that the base was 32 feet. I said that the height is 10 feet. I always love multiplying by 10, so I'm going to take half of the 32 and make that 16. That means that this one is 160 square feet. Do not forget your units, guys. The second figure is this rectangle right here. So on this one, a rectangle is area is length times width. If I look at my sheet, all I need is length and a width. It doesn't really matter what I call what, so I'm going to say that's my length. And my width is that same 32 that I found above. So now I just put those 2 numbers in my formula. 12 feet times 32 feet. So that one I'll do over here. 32 times 12 gives me 4, 6, 32, 4, 8, 384 square feet for this piece of it. Now I do my third shape. This is the rectangle of the garage. On this one, area equals length times width. So I'm going to say that the length is 18, the width is 9. So area equals 18 feet times 9 feet. 18 times 9 gives us 72, 162. Now here's the last part in these composite figures pieces. Figuring out, am I putting these pieces together, or did I do a big shape that I'm taking them out? Wow. Which one am I doing? Putting these together, right? Is there anybody who doesn't see? I found the triangle, the rectangle, and the rectangle. So for the whole area, I just have to put those together. Make sense? So I put them together. I'm going to take those three numbers that I just found, 160, 384, 162, and I'm going to add them together. It gives me 6, 12, 20, 367. So my total area, and don't forget your units, 706 square feet. Does that answer the question? No, it does not. What was the question that was asked? How much paint would I need to paint the entire back of the house? Each one does 400 square feet. I did tell you, go to the nearest gallon. So 400, it's bigger than that. 2 gallons would be 800, so he needs 2 gallons of paint. That would be, guys. So, is there anybody who doesn't understand any piece of this? Jaden, thank you for being honest. Which part don't you get? Okay. Guys, I'm serious. If you'll write the base formulas, which we will make sure you have, just as a side note, if you look at the board tonight, starting on Friday, we're doing a test review. Our first major test of the year is going to be next week. And area is going to be a big piece of this because we've just spent like 4 lessons doing area. So you guys have to understand this. If you will write down the base formulas, which we will make sure you have all the formulas for the test, write the base formula, identify your base and height, length, and width, put the correct numbers in, you should be fine. Overall, your math skills aren't that bad. There's a few that still need some basic work on multiplication, but most of you are doing pretty decently on that. Sophia, question? Yes. You can, but you're going to miss part of the next. Wait till I get the instructions done. Go ahead. Let's go to this, page 81. She said me. Okay, on this one, Tanner says, spray painting an arrow to point to the entrance of his store. The can he wants to use covers up to 12 square feet. Does Tanner have enough paint for his arrow? There's our question. So again, you're going to break the arrow into pieces that you can find the areas of. Find the areas, put it together. You're also doing numbers 4 and 5. Okay? This is basically going to take us most of the way up to lunch at this point. So I will give you a hint. Normally when they say find the area of a shaded region, you're actually better off going with the big figure and taking out the pieces that are in white. Because shaded areas tend to be a little more difficult to find the shape of. Okay? So, you may work together as a table. You got 3 problems. I'll give you guys about 14 minutes to finish those. Go. Guys? Okay, hands down. Let's take a look. This first one, there's really only one way to divide this one up. If I just finish out that line, and now I have a triangle and a rectangle. So here's your best way to solve these problems, guys. Write out draw the lines for how you see the shape. It's one of the things that, again, I love about our textbooks. You can write right in them. Then label which ones they are. So now I can start doing the work for it. So shape number 1 is a rectangle. Page 70. Go in, find your formula, area equals length times width. On the picture itself, label your length and your width. So I can say that my width is 2, my length is 5 1/3. Then I can put those numbers directly into my formula. So 5 1/3 feet times 2 feet. How do I multiply mixed numbers? Kelly? Slam dunk. I got to make it an improper fraction. So 3 times 5 plus 1, that's going to give me 16/3. What about whole numbers? What happens to those? Destiny? What happens to them? A little too focused on the time. Yeah. Whole numbers, to make them an improper fraction, I put it over 1. Okay, nothing to reduce because I got two even numbers on top and 3 on the bottom, so I'm going to multiply. 16 times 2 gives me 32. 3 times 1 is 3. Simplify. Given our dividing fractions quiz, I'm a little worried on this one. When do we simplify? Always. We always simplify, which in the case of an improper fraction means going back to a mixed number. So 3 goes into 32 10 times with 2 left over. So the first area I have is 10 2/3 square feet. My second shape is a, what's that shape? Guys, come on now.
Triangle.
It's triangle. Everybody should be able to see that. So I write my base formula for a triangle, 1/2 the base times the height. So in this case, they actually gave me the base, even though a lot of you were calling that the height. But that mirrors this line right here, which is the base. Remember, my height is always the perpendicular distance from the base to the opposing vertex. In this case, they didn't actually tell me what this is, did they?
Nope.
But they said the whole thing is 6, and the rectangle piece is 5 1/3. So I can find that just by subtracting. Now, you can turn these both into improper fractions and then do the subtraction. But for me, in mixed numbers, it's easier just to break it into pieces. So if it's 6 and minus 5 1/3, really quick side note. If I do 24 minus 8, can I do 4 minus 8? No, so what do? I take away from the 2, and I borrow 10 and add it to the 1s. I make that 14, right? So that's a 6. 1 minus nothing is 1. Is everybody okay with that? Okay, you've been doing this since first grade. Now we're just doing it with a fraction. So if I don't have anything, what do? I have to borrow from the 6. I make that a 5. But now I borrowed 1, right? What is my rule for subtracting or adding fractions? Again, common denominator. What is the denominator I need? 3. It's right there, guys. But I just borrowed 1 whole, didn't I? So how many thirds did I borrow? 3 thirds, because that's 1. Does that make sense to everybody? Anybody that doesn't, that makes sense to you. Okay, now I just subtract. 3 minus 1 is 2 thirds. Once I get my common denominator, I don't do anything else with it. 5 minus 5 is 0, so that means this is 2 thirds of a foot. Does that make sense? Okay. Now I have my base and my height identified. This is my my height. So I put in, area is 1/2 times 3 feet times 2/3 feet. Is everybody okay with this?
Yes.
Liam? Q1, first quarter. That was actually your whole team 6B getting together, and we're trying to figure out areas where we're all teaching the same concepts so we can come up with a big project for each quarter. But don't worry about that. We haven't got it done yet. Yes, Jet?
I just why we do dividing or make 1/2 for a triangle. Just because whenever we do a whole square, when we do that dividing, it makes it into a triangle.
Yep. Okay. Now I just have numbers. I'm going to pull just the numbers out. So this is 1/2 times 3 times 2/3. Meaning the 3 goes over 1. Now I'm multiplying. If I find a common factor top and bottom, I can reduce those away. So in this case, I have a 3 and a 3. Those can both become 1. I have a 2 and a 2. Those can both become 1. So now all I have is 1s. So what is this? 1 square foot. So I found out the 2 pieces. Now I need to put them together. So I have 10 2/3 plus 1. 2/3 of nothing is 2/3. 10 and 1. So that means the whole piece is 11 2/3 square feet. But did that answer my question? No, because what was the question? Does he have enough paint? So the answer is actually yes, he has enough paint. So for any of you that all you did was put down the 11 2/3, you did all that work for nothing because you didn't answer the question. Okay, let's go ahead and look at the next one. Now this is where it's going to get a little more complex because there are a lot of different ways to solve these. I'm going to show you the way I would solve them. Again, normally when they talk about area of a shaded region, that to me says find the big one and take apart the parts I do know. So I'm going to do this whole big figure, then I'm going to take away this trapezoid and this triangle. So number one is this large rectangle. So area equals length times width. And I have a width of 4 and a length of 6. So area equals 6 inches times 4 inches, or 24 square inches. So that's this whole thing. Does everybody understand that? Okay, shape 2 is a trapezoid with 2 parallel bases here and here. So my trapezoid formula, 1/2 base 1 plus base 2 times my height. So there's 3 things I need on this. Remember, my bases are the parallel sides, meaning the 2 and the 3 are my 2 bases, making the 4 my height. Is everybody okay with that? You have to identify that accurately or your formula is going to get all messed up, guys. Now that I have those identified, I just put them in the formula. 1/2, I said base 1 was 2 inches, base 3 is 3 inches, and my height is 4 inches. Order of operations, I have to do the parentheses first. 1/2 of 5 inches times 4 inches. Now that Mr. Moore tip I keep giving you guys, if I have a 1/2 in my formula, find an even number. So half of 4 is 2. So then all I have is 5 times 2, or 10 square inches. So that first trapezoid is 10 square inches. Now I have my third shape. This one is a triangle. So area is 1/2 the base times the height. This one's a little more complex because here's my right angle. They gave me one of them. They didn't give me the other. But I know the whole thing is 6. Up to there is 4. That means that this is 2. So I'm going to call this the base and this the height. Does it matter? No, as long as you have them identified. 4 times 2 is the same as 2 times 4. Put them in my formula. 1/2 of 2 inches times 4 inches. So now it doesn't matter which one I do. I'm just going to do half of 2 gives me a 1. So this one is 4 square inches. Does everybody understand all 3 of those numbers and where they came from? Okay, so now's where you have to figure out how did I look at this. I said this was this big picture of 24 square inches. I subtracted the first trapezoid. That gave me 14. Then I subtracted the triangle. So my total area is 10 square inches. Does that make sense to everybody? Okay. Lunchtime, we'll finish this last one after lunch. Okay, our last one. This one is the most complex of the 3. Guys, quiet. This one's the most complex of the 3 simply because there's so many shapes in it. But if you really look at it, it's not that difficult. Basically, if I go with the really big square again, I really only have 2 other triangles in here. And technically I only have 1, but we'll talk about that in a second. So on this one, I have a square. So my first area is just length times width. So they didn't actually add it all up for me, but if I did, this is 12 centimeters for my length. This is also 12 centimeters for my width. So I'm just putting those 2 in. 12 centimeters times 12 centimeters, or 144 centimeters squared. That's our first one. Our second one this small triangle, and it doesn't really matter which side I do it on, so I'll do it on this side because that's got both of them there. So it's just a base of 3 and a height of 3. My base formula, 1/2 the base times the height. Now I know that they are each 3. I can't really do half of 3, so I'm going to multiply first. So that's 1/2 times 9 centimeters squared. Half of 9 is 4 1/2 or 4 5/10 centimeters squared. Here's the key on this though. How many of those do I have? I have 1, 2, 3, 4 of them. So I actually need that 4 5/10 times 4. I have 1 decimal place. 20, 16, 18. So all 4 is 18 centimeters squared. Does everybody understand where that came from?
Yeah.
Okay. Our last one, number 3. This is also a triangle. 1/2 the base times the height's our base formula. On this one, it's a little different. So I have a base of 6 because it's this part. My height is still 3 because it looks to be basically the same as the other one. So I now know my area is 1/2 times my base of 6 times my height of 3. Half of 6 is just 3. So the area on this one is 9 centimeters squared. But just like the other one, I have 1, 2, 3, 4 of this one. So I do 9 centimeters squared times 4 means that all 4 equals 36 centimeters squared. Is everybody clear up to this point? I am moving pretty quick. That's why I'm slowing down. I just step back. Jet, you good? Who's not good? Just Callie? Okay, so but everybody else is tracking at least?
Oh, I'm slowly.
Okay, so the way that I decompose this figure, I said I had the whole thing was 144 centimeters squared. Is everybody good with that one? Then I took out the 4 small triangles. That area right here was 18 centimeters squared. So this one I'm just subtracting, gives me a 6. 13, 3 is 126. Then I have to take out the larger 4 triangles. So that gives me another 36 centimeters squared. 6 minus 6, 12 minus 3 is 9. So the total area is 90 centimeters squared for the shaded portion. Is it making sense? Are you guys starting to see how you can take these apart or put them together?
Yeah.
Because you can really go either way, and it's up to you how you see it.
Kind of.
I don't know how I see it.
Sophia?
Ask how you got the square for them. Like, you had 3 triangles, so how would you make the square? Like, how'd you find the square out of that?
I did the whole outside one. Is that what you're asking? So I did this whole big outside square. That's number 1.
Oh, okay.
So I did the whole thing. I needed the shaded part, so then I found these little white areas and I took all of them out. That's what those numbers were. That's what that one and that one were, was all of these little white areas that I needed to take out. That's okay. Does that, you see it now?
Yeah, that makes sense.
Okay. Okay, let's turn the page. Oh, I forgot to erase this one. Shoot. I kind of already gave you guys the answer. So you can divide more complex figures with oddly figured regions into smaller familiar regions to calculate the approximate area. So here's your task. Draw lines to divide in the figure to divide the figure into smaller familiar figures. Then name the familiar figures that make up the total figure. So we have 2 parts. Draw the lines and then name the figures. So I want you guys, I'm going to give you about 2 minutes. Divide this up the way you see it. put numbers in the shapes that you're seeing and tell me the names of each of the shapes. Okay? So you have 2 minutes. I had it closed. Okay, on this one, I'm just going to show you the way that I had this one divided up. I basically said if I did a straight line down here and a straight line down here, I ended up with 4 figures. So for me, numbers 1 through 3 were all triangles. And number 4 is a trapezoid. Was that the only way you could do this? No. Honestly, if you really think about it, there's probably about 20 to 30 different ways I could divide this figure up. So, the bottom line is, any of them can be valid. Just make sure you've done it in shapes that you can find the area of. Does that make sense? Okay. Now that we've seen that, I'm going to give you 2 more complex figures that may not be quite as easy to break up. Unfortunately, we've only got like 12 minutes left. So I'm going to let you guys get working on this for about 7 minutes. And then we'll come together and we'll solve what we can. That way we have time to go over the homework. So with 3 minutes left, I'm going to go through this fast. I'm going to show you how I would do them. This is not the only way. There's several ways you can do this. But this is the way I would approach it. So for me, I would divide the first one here and then extend this line here. That gives me 3 shapes. I've got a triangle, a rectangle, and a trapezoid. So for my 3 shapes, shape number 1, it's a triangle, so it's 1/2 the base times the height. On this one, they didn't actually give me this distance, but they said the whole thing is 15, this part's 10, so I now know that's 5. So I'm going to say that base is the 2 and the height's 5. So area is 1/2 times the base of 2 times the height of 5. Half of 2 is 1, so that means that the first area is 5 square centimeters. My second one is this big rectangle. They gave me the biggest things. That one is base times height. So I have a height of 15. The base is just this part of it, so that makes it 4. So on this one, it's 4 centimeters times 15 centimeters, which gives me an area of 60 square centimeters. And then my third one is this trapezoid over here. So a trapezoid, my base formula, 1/2 of my 2 bases added together times the height. So I have 2 bases. My bases are the parallel, so it's this one and this one. They gave me this, so I'm going to call that base 1 because that one's easy. They didn't give me this, but they said the whole thing is 15. This part is 7. That means that this part is 8. So my base 2 is 8. Then they also didn't give me this, but they said the whole thing is 8, and this part was 4, meaning this one is 4 centimeters. So that one is my height. So again, they're not going to give you all of the information in how you're dividing it up, but they will allow you to be able to get all the information. This is why this is difficult. You have to see it. You have to break it up. Okay? So what we ended up with on this third trapezoid, I have an area of 1/2. My base 1 was 5. My base 2 is 8. So 5 centimeters plus 8 centimeters. And my height was the 4 centimeters. Order of operations, I have to do the parentheses first. So 1/2 of 13 centimeters times 4. I'm going to do half of 4 is just 2. 2 times 13 gives me 26 square centimeters. Now that I have found all 3 of those areas, I just put them together to build my whole shape. So I have 5 plus 60 plus 26 gives me 1191. So my total area is 91 square centimeters. Does that make sense?
Yeah.
No.
Can you move your hand? May you move your elbow?
Any questions on how I broke that up?
No.
Okay, at this point, I'm not going to do the other one because I want to go through the homework in a little more detail for you guys, so it's on the video. So let's go ahead and look at page 85. We again have a journal entry. Define composite figure and draw a picture of an example. 2 parts to it. You can either do it in this area here that they've given you. You have area here, you have area here. Here's where this is going to be a little more difficult for your homework and why it may take you a little longer than most of your homework assignments have. I need to calculate the area of each of these. Okay? The first one, I think they give you quite a bit because they told you what this distance is. I can figure out this distance based on the total. So that one's just 2 shapes. This one, you have a couple of options. I'll be honest, guys, me personally, I'd make that a trapezoid and then just take out that little square. But you can do it however you want. Number 2, again, they've given you a couple of interesting figures here. I would make this easy. If you do this, I have 2 trapezoids. Remember, your bases would be here and then here and here. So you can easily do it in 2. You can do more if you want to, but that's how personally I would do that one. Going to the last page. This is page 86. On this one, now it's a rectangle and a hexagon. The length of each side of the hexagon is 2 centimeters. Determine the area of the shaded region. So again, if they do shaded regions, to me personally, what I will normally do is do the bigger area. So I would do this whole thing. A hexagon is just 2 trapezoids put together. So then you find the area of the 2 trapezoids. You take that away from what you did in the rectangle. That will give you the shaded areas. The problem with trying to calculate the shaded areas is they didn't really give you any information that's going to help you to find those triangles. Because I don't know how long that is. And this one I could say was half of 3.5, but that's not going to be a very fun number either. So that would be my recommendation. Number 4, the triangle within a trapezoid, determine the area of the shaded region. Again, when they ask shaded regions, Mr. Moore personally is going to take the whole trapezoid, and then I'm just going to subtract this triangle. That's my recommendation to you. Questions on your homework? Okay, couple stretches that are actually really good. If you wanted to try those stretches, I would recommend it. Just be aware of what those shapes are and how you're going to break them up. One key on this, it says 2 congruent triangles and a rhombus. So because it says it's a rhombus, that gives you a definition that helps you on that middle piece to figure out a couple of those that they didn't give you the actual measurements on. Lauren? Sure. If you want to punch holes in your test, I got hole punches on both sides. No questions on your homework? No. Okay.